Alright, this is going to be a video going through the Honors Algebra 2 review for the Unit 1 Topic 3 Part 1 Exponential Functions Test. So it says the calculator is allowed on the first 4 questions. This is just a reminder that when you receive your test, it will be 2 pieces of paper, and until I get the note, you'll actually do the no calculator part first, which is kind of longer. As you can see, only the first 4 questions here use a calculator. Those will be the last questions you'll do. You'll be able to see them, you can set them up, but you can't take your calculator out from under your desk until you've given me that first piece of paper. So here we go. Solve the equation. Your answer should be correct with 3 decimals places after the decimal point. A coordinate grid is provided should you choose to solve it graphically. Well, guess what, guys? That's how we're doing it. We're going to solve it graphically. Now, I could just put this in y1 and this in y2, but the problem is it's 45. So I'm going to start by dividing both sides by 3. And I get 2 to the x equals 15. And now I'm going to go into my calculator and I'm going to type 2 to the x. Oops. There goes 2 power x. And then I'm going to put 15 in. And immediately what I need to do is I need to make sure that my y max is at least 15. So this, remember, so y1 is 2 to the x, y2 is 15. And it's very convenient that my graph goes up to 15 here because I'm going to have a horizontal line at 15. And 2 to the x is going to look kind of like this. But if I just press graph right away, I'll see the exponential function, there it is, but I won't see the line because my window only goes up to 10. So the first thing I want to do is maybe change that to 17. There's the graph. Oh, and here comes the line. And now I'm going to do second trace intersect. And I only have 2 curves, so first curve, enter, second curve, enter. Guess, you can just press enter or you can like arrow over to there. And I see that x equals 3.907 because it says 3 places. All right, so let's do this again. Again, it's probably easier if you divide both sides by 4 because that way you don't have to have such a high y max. Now I have 5 to the x equals 10. This is going to be y1. This is going to be y2. So 5 to the power of x and 10. And here's 10. And 5 to the x is another growth function. And second trace, intersect. First curve, second curve, guess. And I have an intersection here when x equals 1.431. Now, I have to use the graph because that's how I'm solving it. So I'm solving it graphically. Okie dokie. Number 3. In 1985, the population of the city of Gaithersburg was 250,000 people. Over a 20-year period, the rate at which the number of residents grew was 35%. Write an exponential model that represents the number of residents where t represents the, okay, important, t represents the number of 20-year time periods. So, all I got, I'm going to let P be population since, oops, I spelled since wrong, that's terrible. What was it, 1985. And y, or t, is going to be the number of 20-year periods. I must find my variables because it says to find your variables clearly. Now this is a growth function, so p equals 25 or 250,000, and then 1 plus 0.35, so there's like 1 plus, and I'm good at math, so I can add 1 plus 0.35 in my head and get 1.35 to the power of t. What is the percent rate of change every 20 years? Well, it's just 35%. That was dumb. Woo! Now we're cooking. Change your model to show the growth in number of City of Gaithersburg residents each year. So if I'm going from 20-year periods, so 2,000 or 250,000, and now I'm going to do 1.35 to the 1/20th, because I want to take the 20th root, and then so my model is still accurate, I'm going to raise that to the 20t. I'm going to grab my handy dandy calculator, and I'm going to do 1.35 to the power of 1 divided by 20. Remember, if you have an older calculator, please make sure you have parentheses around the 1 divided by 20. And I get P equals 25.3, 1.015. That's 3 decimals, 20t. Now, the percent rate of change each year, well, if it's 1 plus R, and I have 1.015, that means I have a 1.5, so I'm just going to kind of grab that percent each year. All right, use one of the models to determine to the nearest million, how many City of Gaithersburg, well, I was doing to the nearest person, so that's kind of cheap. How many City of Gaithersburg residents there will be in the year 2025? Well, when I look back here, I see that I'm starting in 1985, and so probably the easiest thing to do is use the original. So like 1985 to 2025 is 2 20-year periods. So I'm just gonna do 1.35, and that's 2 to the second power. That's probably the easiest thing to do. Like, you totally could put 40 in this new equation we wrote, but I don't think it's gonna be as accurate because we rounded that. So I think I'm better off using the original equation. Again, you could totally, as long as I see some work, you could put 2 here, you know, and raise this to the power of 40 because it's 40 years, but I don't want to be inaccurate. I would rather be accurate. Can you see that ish again? Squared. So I'm just gonna round to the nearest person. I don't know why it says the nearest million. That's funky. Let's cross that out. 4, 5, 6 to 5 people. Don't forget your units. All right. Sarah plans to deposit $100 into a bank and leave it there to gather interest for 5 years. I have 3 banks. Which bank should I choose? So I'm gonna go be very systematic about this. I'm gonna say 100, 1 plus R, so bank A is 3%, over N, quarterly is 4, and I'm gonna leave it for 5 years, so 4 times 5. So I'm gonna go, remember, I wanna put this in one step. Don't try to make it like 1,000 steps. 1 plus 0.03 divided by 4, close parentheses, and I'm smart, I can do 4 times 5 in my head and put 20 in there, and that is 116 and 12 cents. So bank B, 100, I have 0.025 divided by 12 for monthly, 12 times 5. Okay, here we go. 100, parentheses, 1 plus 0.025 divided by 12 because it's monthly, to the power of 12 times 5 is 60. You could totally put in 12 times 5, but I'm not going to. That's worse. Bank B, you're out. Not picking you. Make $3 more in Bank A. Let's see if Bank C is the winner. Now, Bank C is compounded continuously, so I'm not going to use the same formula that I did for A and B. I need to use the other formula for continuously, which is principal times the number E to the power of rate times time. So when I put this in my calculator, I'm going to say 100 times E, which is a second ln, and then okay, so make sure if you have an older calculator that the parentheses have popped up, 0.02 times 5 and that is still the loser. Bank A earns the most. All right, so no calculator, so I'm gonna ditch my calculator. Goodbye, and here we go. The graph of f of x equals 3 to the x is shown. Identify the following properties. Well, the domain is gonna be all real numbers because the graph stretches from left to right. The range is going to be y is greater than 0 because I see I have like a flat line here. I have nothing down in the negative land. My y-intercept is right here at 0, 1. The asymptote is y equals 0, and it is an increasing function. That was easy. Where's my easy button? Woo! No calculator. Good thing Miss Strauss made us do all that practice. So first thing I'm going to do is I'm going to make my own table for these. I'm going to say x, y, and I'm going to start at 0, 0, and then I've got 1, 4, 2, I don't know, 3, 16, and I see it's 2 steps from 4 to 16. So I'm going to say 4b squared equals 16. I'm going to divide by 4. I get b squared equals 4. Obviously then if I take the square root, I get b equals 2. That's important because now I can divide. 4 divided by my b value gives me 2 for my starting value, and I have 2 times 2 to the x. That one was not so bad. Let's take a look at b. Again, you can always pause the video if you need to see something again or you need a little more time to write. So I have negative 1, 1/2, and then 1, 2, 3, 4 steps later, I have 8. So I'm going to set up the equation 1/2 b to the 4th equals 8. Now I'm going to multiply both sides by 2. And I get b to the 4th equals 16. And if I need to, I can sit here and break the 4 down, or the 16 down into 4 times 4, and then break that down into 2 times 2 and 2 times 2, and then I can see that b is 2, because 2 multiplied 4 times gives me 16. So now I'm going to multiply down. 1/2 times 2 is 1. So my function is y equals 1 times 2 to the x. Obviously, you do not need the 1 if you don't want it. All right, letter C. Let's set it up in a table. I have negative 1, 6, 0, I don't know, 1, I don't know, 2, and 3/4. So from 6 to 3/4 is 1, 2, 3b values. So I'm going to say 6b to the 3rd equals 3/4. On both sides, I'm going to divide by 6. But on the right side, I'm going to write it as times 1 over 6 because it's easier to deal with the fraction. I see a 6 in the denominator and a 3 in the numerator. So I'm going to divide them both by 3, and I get 1 and 2. So now I've got b to the 3rd. 4 times 2, that's going to be 1/8, which I don't really need to do because I know I'm looking for what multiplies 3 times, and this is 4 times 2, so obviously it's going to be 1/2 because 3 1s give you 1, and 3 2s will give you 4 times 2. Go back up to my equation. 6 times my base of 1/2 gives me 3, and so now my function is y equals 3 times 1/2 to the x. We've got one more like this. I've got negative 2, negative 1, 0, 1, 2. Now I immediately notice that I've got 0.03 here, and I'm going to write that as 3/100ths. Because it's just much easier to work with fractions than it is with decimals in this situation. So I have, let's see, 1, 2, 3, 4 steps, so 3 over 100 times b to the 4th equals 300. Let's multiply by the reciprocal. So everyone who is having some kind of panic attack about the numbers here should be quite pleased, because the 3's in the 100s cancel. Here, 300 reduces to 100. 100 times 100 is 10,000, and it's b to the 4th power. And again, you didn't even really have to multiply that together, because you know that 100, throw in pencils, 100 is 10 times 10, and then this 100 is 10 times 10, so obviously b is 10. So now if I multiply by 10 going down, I'll have 3/10, and times 10 again would just give me 3. So I've got y equals 3 times 10 raised to x. All right. Graph the function and state the key features. So here we go. Let's make a table. I know my starting value is 2, so 0, 2. And I'm multiplying by 1/3. Oh, you know what? I should have made a -1. What's wrong with me? So 2 times 1/3 is 2/3. Now 2 divided by 1/3 is 2 times 3 over 1, which just gives me 6. So I've got -1, 6, 0, 2, 1, 2/3. Put my asymptote in. My domain is going to be all real numbers. My range is going to be y is greater than 0. Asymptote is y equals 0. And the y-intercept is 0, 2. All right, so number 8, I'm noticing has a negative exponent. So the first thing I'm going to do is I'm going to rewrite this as f of x equals 6 times 2/3 to the x. Okay, once I have it rewritten, I'm going to go ahead and make my table. -1, 0, 1. I'm going to have 0, 6, because I know that's my starting value. 6 times 2/3 is going to be 12/3, or just 4. And then 6 divided by 2/3 is like 6 times 3/2, which I could cross cancel, or I could make it 18 over 2. And either way, it's going to be 9. I might go again, just because like 4 is kind of high up there, you know. And I'm going to do 4 times 2/3. That gives me 8/3. This graph goes down very slowly. So let's see, 4 and now 8/3 would be like, and then times 2/3 is going to be 16/9. That's starting to get smaller. So I'm thinking 8/3 is a little more than 2. And 16/9 is a little less than 2. So this graph is going down slow. There it goes. But other than the y-intercept being 0, 6, the domain and the range, everything's going to be pretty much exactly the same. Okay. Determine which functions represent growth or decay. How do you know? We need an explanation. So pretty much all of our explanations are going to be based on the base. So the first 3, I can just look at the base right away. And because 0 is less than 1/5, so basically because 1/5 is between 0 and 1, we have a decay. Because 5 is greater than 1, we have a growth. And because 3/2 is greater than 1, we also have a growth. Those ones are pretty direct. Whoop, you didn't see that one, sorry. So now this one needs a flip over, so I need to rewrite it as y equals 5/1 to the x. 5/1 is bigger than 1, that's a growth. I need to flip this one over also. That puts our base between 0 and 1, which makes it a decay. And when I flip over 5, I get 1/5, which again is going to be a decay. So, oops, sorry. If all you did was watch me do this and write stuff down, you need to now redo this review packet completely by yourself. You also have a number of really good warm-ups that you should be reviewing. You need to make a summary sheet. Can you summarize this entire topic, exponential functions, on one piece of paper with all the vital information? These are good things to do to prepare for the test.